Hello, and welcome to another quarantine lecture for Math25 College Algebra. So today we're going to be going over section 5.2 and 3. That's my hope for today. But as usual, before we begin, are there any homework questions?
Um, 5.1 on number 8.
Okay. Anything else? All right, then we'll start with that. And as per usual, I'm going to mute all of you just so we don't hear any rustling of papers or moving your laptop or your desk and stuff. All right, so let's go. I'm going to go ahead and share my screen and let's take a look at that homework problem. Mic is on, start broadcast. All right, so let's take a look at our homework. Chapter 5 practice problems, 5.1, number 8. All right, number 8 reads, a circle, well, your instructions, what do your instructions ask? Find the sine equation of each of the following described circles. Okay, let's see what we have. So it says a circle with a center in the second quadrant, a radius of 2, and the circle is tangent to both axes. Okay, that one's really weird. That's a great question. Okay, so a center in the second quadrant, okay. A radius of 2, so r is 2. And the circle is tangent to both axes. So that means it's like touching. So my circle is touching these two axes. So my circle is like this, right? It has to be touching these two axes. Well, that's not really touching this axis. So then my circle looks something where it's touching here and touching here. It looks like that. Okay, so if it has a radius of 2, it has to be up to -2, and it has to be to the left 2. So -2 because it's left 2 right here, -2, and the radius of 2, so that would be my center. And that would also satisfy a radius of 2. So my formula for my circle is x minus h squared plus y minus k squared equals r squared. Okay, so I need to fill out those pieces. So I'm just filling this up so I can start filling this in. So if this is so, I have a center at -2, 2. So that's h and k. So my h goes with my k, which is a -2. And my k goes with my y, which is a +2. And then my r is 2. That's what it said, right? A radius of 2. So I have a 2 is going to be squared. So this means I have to rewrite this with a plus because it has a minus and a minus. So that my answer is x plus 2 squared plus y minus 2 squared is equal to 4. That's our answer. And I think what made this one weird was the description, right? That it's tangent to both axes. It just means it's touching. So I looked up tangent on dictionary and it reads a straight line or plane that touches a curve or curved surfaces at a point. But if extended, it does not cross at any point. So it just means it's touching at those lines. Okay. So let's go ahead and continue with 5.2. So we went over the first example, but I didn't finish for two reasons. One of them is I wanted this to linger for two sections because it has a lot of qualities of a circle, but it's gonna have a lot of qualities of our next section, a hyperbola. But also we're already like an hour and 20 minutes in, and I don't want to make our lectures too long because I don't want to throw in a break. I feel a Zoom break would be really awkward. Okay, so let's continue with 5.2. We talked about ellipse, and it's a type of circle, and we have this formula here, and that's what we need to remember. We have a formula that's x minus h squared over a squared plus y minus k squared over b squared. It is always equal to 1, and your center is always hk. If there isn't a number, then we assume it's a 0, just like we did for the circle. Now recall when you have your Cartesian plane, we have our x-axis and we have our y-axis. You see that y goes up and down, and x goes side to side, left to right. And that same idea attaches to the denominator. So that's why I have those errors here. So we have an a under the x, which tells us that is the square root amount that I'm going to go left and right because it's underneath an x. And the number that's underneath the y is going to go up and down, a square root amount, because it's always given as a number squared. So let's go over these pieces. A center is h comma k. A is a distance left or right from the center to either vertices, and b is distance up and down from the center to either of the vertices. And c is the distance along the major axis of the foci, where c is equal to a squared minus b squared, or c squared is equal to b squared minus a squared. How do you know how to subtract? Remember, it's always larger minus the smaller. Okay, let's continue with our next example. Example B. Okay, so we're going to graph x plus 2 squared plus y minus 1 squared over 4 is equal to 1. All right, so we want to start off by maybe getting ourselves an idea what we're going to draw. A good starting point is our center. Our center would be, it's always h by the x and k by the y. Remember, it's always the opposite sign. So I have a plus 2 for h, so I write minus 2. I have a minus 1 for k, I'll write positive 1. So I have a center at negative 2 up 1. All right, now I need to use my numbers underneath to know how far up, down, and side to side I go. So I'll do this one with blue. Because it's underneath the x, x goes from left to right. Our x-axis goes from left to right. So I'm going to go left to right. Number 9, take the square root of it, 3 units left and right. So I have 1, 2, 3 from the center. So I'm at this point right here. So that'd be a 0, comma 1. And I'll go 3 more to the right. 1, 2, 3. But make sure it aligns with your center. So this gives me the point 1, 2, 3, 4, 5, negative 5 up 1. Okay, now your y tells you how much you're going to go up and down. Because your y-axis goes up and down. So I'll go up and down for your y. You take the square root of the number underneath, which is a 4, so we have 2. So I'll go up and down 2 from the center. 1, 2, I'm right here, which is the point -2, 1, 2, 3, -2, comma 3. And I'll go down 2. 1, 2. Just about here. So it gives me -2 down 1, -1. And therefore, from there, you can make your circle or your squish circle. And there you have it. You have to find one more piece, which is your foci. And it's always your bigger number minus your smaller number. Our bigger number is 9 minus 4. So in this case, so it's a number squared, which is what we have. So we have 5 minus 4 is 5. C squared is 5, but I want C. Take the square root of both sides. And if we punch that into our calculator, let me grab a calculator. That's about 2. I want to say 2.2. 2.23? Yeah, about 2.2. So about 2.2 units left and right, because we move left and right the greatest number. So this left and right would be our major axis. So 1, oh, I didn't move left enough, because it was 1, 2, 3. I should have gone over here. So 1, 2, I should have gone all the way over here. So it can be 1, comma 1. All right, now we can draw our circle. So our foci is telling us to go along our major axis 2.2 units. So 1, 2, 0.2, 1, 2, a bit more, 0.2. Okay, if all my chicken scratch didn't make sense, let's go over what your text has. Since the equation is written in standard form, we can determine the following. We have a center at -2, comma 1. A squared is 9, giving A 3. We took the square root, right? The distance left and right from the center of the vertices is located at -5, comma 1 and 1, comma 1, which is what we have in blue. B squared is 4. We take the square root, and 4b is 2. The distance up and down from the center to the endpoints of the minor axis is located at -2, comma -1 and -2, comma 3. Since a squared is bigger than b squared, we're going to create the equation c squared equals a squared minus b squared. It's always your bigger number minus your small number. We get 5. C squared equals 5, therefore c is equal to square root of 5. So we have these other points along our major axis. This is called your focus. Your 2 focus points, plural focus is foci. So we have a focus point at -2 minus square root of 5, comma 1, and -2 plus square root of 5, comma 1. So we have this graph right here, which is a much prettier version than our picture that we have. But I mean, we know what we meant. All right, any questions about our second example?
Yeah. How did you get?
Yeah.
How did you get? It's Emmanuel. How did you get -5, 1, and then the other side 1, 1? I think I missed that step.
Oh, are you asking about this part right here?
The one on the circle that you graphed. You put -5, -5, 1, and 1, 1. I just wanted to know how'd you get it?
Okay, good question. So we got those numbers because, so you see x and x has a 9? Because x has a 9, x goes left to right, so I take the square root. So I'm going to go left and right from the center. We're going to go from the center, left and right 3. So we go 1, 2, 3. We have this point here. 1, 2, 3. we have this point here. Now our y has a 4. I take the square root of 4, which gives us 2. Y is up and down. So I'll go up and down 2 points. 1, 2, we're there. 1, 2, we're here. So that's where these numbers came from. They're given in your circle in disguise.
Got it. I missed that step. So what? Right after
No.
we square root the whole thing, that's when whatever you get
Right.
is pretty much how much you're gonna move from left to right, up and down, right?
Yes. And that focus is that funny point. Those are those hinge points that you tie your string, or the idea behind it. So your foci is 35, which is about 2.2. So you move 2 points and a bit more on each side, which is these points right here. So you move 1, 2, and a bit more. There's our point. 1, 2, a bit more, and here's our point. So those are those special hinge points that it was saying on the introduction. All right, thank you for your question. So C. So our equation is 2x squared plus 3y squared minus 8x plus 6y minus 1. Okay, this is a problem because we want that standard equation of a formula, that x minus h squared over some number squared plus y minus k squared over some number squared. And in case I didn't emphasize enough, because I don't think I have, it's always equal to 1. We need to make sure it's equal to 1. If not, we have some work to do. This is not what we have, right? We have something else. So we need to make sure it looks like our equation there. Okay, let's go ahead and complete the square. So we need to complete the square so we can make sure it looks like our equation above, like our standard equation. Let's read from our text. As with circles, the standard equation of an ellipse contains only one copy of each variable. So you must again complete the square. So let's group our x's and our y's. So notice here we only have our x's, we're writing with our y's, and we're leaving some space because I know I'm going to have to add some number, right? And then we add it to both sides. So let's set ourselves up to what we're going to have to add. Okay. However, we cannot complete the square until 1 is a coefficient of x squared and y squared. And that's not the case, right? So I need to make it a point to divide by that too. So I'm going to factor out a 2 for my x's and factor out a 3 for my y's. So that we're here. So 2x squared divided by 2 gives me x squared, and 8x squared divided by 2 gives me negative 4x. Now I need to complete the square so I can add a number. So we take our middle term, our b, negative 4. Negative 4 divided by 2 gives me negative 2 squared. Negative 2 squared is 4, so I will write a 4. But remember, I need to multiply it out to the outside. So I need to take the 4, multiply it by the 2. We get 8. So I'm going to add an 8 right here. Let's do the same thing with our y's. We need to make sure we factor out that 3. So y squared, 3y squared divided by 3 gives me y squared. Positive 6 divided by 3, we get 2y, positive 2y. And let's do our work for that. So we have our b. So for our y's, we have 2 over 2 squared. Remember, our formula is b over 2 squared. And so we have 1 squared, so it's just a 1. So we're going to go ahead and add a plus 1. Now I need to add a number here too. But remember, we need to multiply it to the outside. So 1 times 3 gives me 3. I'm going to add 3. All right, it reads, we must recognize that each set of parentheses has a leading factor. Therefore, when we add 4 and 1 and the parentheses with leading factors of 2 and 3, we must add the values 4 times 2, which is when we're asking for permission to go out, in case you like that analogy, and 1 times 3 to the right to make sure that we add the same amount to each side of our equation. And so we wrote 8 and 3, which is what we have, 8 and 3 above, right? 8 and 3. All right, so let's complete the square. Remember, you don't have to think about factoring. Recall that it's always a number before you square. It's always a number before you square. So this factors to be 2 times 2x minus 2 squared plus 3 times 3y plus 1 squared equals, when you do some work on the other side, right? 1 plus 8 plus 3. All right, 8 plus 1 is 9, plus 3 we get 12. That's how we get this 12 here. It's from our work here. Once we work it out, we get that 12. Okay, so we have our formula. It's really close. It kind of looks like a circle, right? You're like, circle, what's going on? But a circle doesn't have these numbers in front. So let's just know it's not a circle. And most importantly, we have a plus. So I know it's not a circle, it's an ellipse. What do we do next? We must divide by your number that's equal to. It's equal to 12, so we must divide by 12 to make a 1. Now dividing by 12 we have, so we divide both sides by 12, so this makes 1. Cool. And now we're left with these fractions. 12, 2 over 12, and 3 over 12. We can simplify them, right? 2 and 12 have a common factor of 2. 2 divided by 2 is 1. 12 divided by 2 is 6. We have this fraction. For 3 over 12, they have a common factor of 3. 3 over 3 is 1. 12 divided by 3 is 4. Essentially, you're going to make that numerator and the number in the front to make a 1. And now we have our goal. We have a standard equation of an ellipse. And that's exactly what we wanted. Okay, now I can point out some important pieces of information. I know my center. I have a center at 2, -1. I have an a of 6 and a b of 4. So therefore a is square root of 6 and b is square root of 2. Now if you don't like writing square root of 6, you can always write it as a decimal point, and that's okay. And we need to find our focus. Our 2 focus points are foci, and it's always our biggest number minus our small number. So 6 minus 4, we get 2. So our focus is square root of 2. If you want a decimal, we have square root of 2, we get 1.41. 1.4. So let's draw our graph. Let's do our work together. Let's redo all this work it has in words. So our formula is x minus 2 squared over 6 plus y plus 1 squared over 4 is equal to 1. Let's go over these pieces together, having a graph there. So we know our center. We have it above. It's always h and k, and it's opposite sign. I have -2 for h, so I'll write +2. I have a +1 for k, so I'll write -1. So we have our center in purple. Okay, in red, we have our left and right points. So in red, we have our x values. So for our x, we have 6. Remember, x goes left to right. So I have 6. I'll take the square root. Square root of 6. You get about 2.4. So we're going to move 2.4 from our center, 1, 2, and a bit more. So we have our red points. 1, 2, and a bit more. We have our red points. Now in yellow, we have our y. So yellow, y goes up and down. We have a 4 for that number, our y. We take the square root and we get a 2. So that means from the center, I'm going to go up and down 2. So I go up 2 units, down 2 units. And that's why I get these points in yellow. Last piece in green are focus points. Our 2 focus points, our foci, are made up by c squared equals a squared or b squared minus c squared. Let's not write down the formula. It's always larger number minus the smaller number. All right, so c squared is made up of 6 is bigger, 6 minus 4, you get 2. C squared is 2. We don't want the square, we only want c, so we take the square root to undo that square. So we get square root of 2. If we punch into our calculator, it's about 1.4. So that means along the longer side, which was the bigger number, so this one right here is longer. On our longer side, we're gonna go move 1.4 units. All right, so our longer side is a horizontal one, left and right. So I go 1 and a bit more. So these are these points in green. From our center, go 1.5 almost, and we have these points in green. And that's when it has written in words above. So I guess if you want a guideline, you would first always make sure it's in standard form. If not, you need to rewrite your whole formula, complete the square. 2, label your center. And then from there, you want to draw. For the number underneath the x, you go left and right, then the square root amount of that number. Number underneath the y, you go up and down the square root amount of that number. And then you draw your circle, connect your points. Exit circle by mental ellipse. And lastly, find your focus points. So that's our foci. So we have c squared is equal to larger minus or smaller. I'm sorry about my dog. Moving forward, finding the equation of an ellipse. The final topic regarding ellipse will be the reverse question as compared to each of the questions above. The question will start with the given information, and the question will ask us to find the equation of ellipse. Example 2, find the equation in standard form of the ellipse with vertices at 0, plus and minus 5, and the foci at plus and minus 3. All right, so your foci tells you which one your major axis will be, right? Because we're adding to the y's, we know it's going to be longer up and down. Okay. Okay, so we say we have vertices at 0, plus and minus 5. So that's telling us the length of my y values. So I know I'm going to have 25 for y minus your center squared, right, for your k? Okay, let's continue. The vertices are the endpoints of the major axis, so the given information gives a sketch of the ellipse. And this is what we have so far. How do we know it's longer up and down? Because it's telling us we have a focus point, a foci, with a changing y value. Your y is the one that's changing, so that's the one we're going to add those points to. And it gives us these vertices. these other points, 0, 5, and 0, -5. Now, because of that, we can assume that it's centered at 0, because otherwise it would give us these points, 0, 5, and 0, -5 somewhere else that crosses the center. So now we're left to find these points. We don't know what they are. And that's the last piece we need, right? We need to know that number underneath x. Now, recognizing the midpoint of the two vertices of the two foci gives us a center 0, 0. Our equation of ellipse can be written x minus 0 squared over a squared, y minus 0 squared over b squared equals 1, which is simplified as x squared over a squared plus b squared, y squared over b squared equals 1. The distance from the center to the vertices of plus and minus 5 is up and down, is units up or down. So b is 5. So 5 squared is 25. Now we need to find that a to get those points we don't know. The final component left to determine is a, the distance from the center to the endpoints of the minor axis. Our sketch above cannot be used to determine this value. We just determined that b equals 5 from the distance of the center 0, 0 to the foci at plus or minus 3 gives us a c of 3. Because b squared determines the major axis, we have that c squared equals b squared minus a squared, which gives us 9 equals 25 minus a. And after subtraction from 25 on both sides, it becomes -16 equals -a squared. So a squared is 16. We could solve this at a equals 4. But since the equation has the final component as a squared, we have the equation of the ellipse as 16 squared. I'm sorry, x squared over 16 plus y squared equals 25 equals 1. So in case everything I read didn't make sense, we only know these two pieces, right? So if we just put this into our formula, we're here. We don't know much more. So if I need that last piece A, do we have a formula that has an A? Yeah, we have that c squared equals a squared minus b squared. Okay, I know b squared. We know b squared. We got b squared is 25. Do we know c squared? Not directly, but we can pick it out because it's telling us that we have a foci at plus or minus 3. So this tells us that c is 3. So we know c is 3, so we have 3 squared. Okay, now we can go ahead and find a. 3 squared is 9, so I have a squared is minus 25. All right, so I want to go ahead and plus 25, plus 25, 25 plus 9. Well, did I do something wrong? Oh, it's always our bigger number. There we go. It's always our bigger number. So 25 has to come first. C squared is 25 minus a squared. We said c is 3, so we have 3 squared is 25 minus a squared.
I have a question.
Uh-huh.
Since we don't know what A is, how do we know that B is bigger?
B has to be bigger because it's telling us that our major axis is plus or minus a 3 on the y's. And our focus only moves along our y's. Thank you, Pastor.
I get it. Thanks.
All right. So we're left with 9 minus 25. We get negative 16 is equal to negative a squared. We divide by negative 1. And we get that 16 is equal to a squared. So 4 is equal to a. That's how they got that a squared is 16. Example 3. Find the equation in the standard form of the ellipse with the major axis of length 4 and vertices of negative 7 comma 1 and 1 comma 1. All right, so we have a sketch and we don't really know much. All we know is we have a minor axis of length 4 and the vertices at those endpoints. All right, so we know our major axis is going to be along the axis, right? And our shorter one is going to be along the y's. Okay, so I want to find the center. That's an important part to know. Okay, well, if I know those endpoints, I need to find the middle point. And I know how to find the middle using the midpoint, right? The midpoint formula. So now we say, now we recognize the midpoint of the two vertices and it gives us a center. So we have those 2 points. Label your points. We have x1, y1, x2, y2, and then we input them into our formula. So I have x squared plus y squared. So I have negative 7 plus 1. We're going to divide by 2. And then our y's. We add our y's and divide by 2. 1 plus 1 over 2. Okay, so we get the point negative 3 comma 1. That will give us a center. Using the center of the equation of the ellipse, we have this so far, right? Let's take pieces by pieces. The distance from the center, 3 comma 1, to the vertices is 4 units. So it's saying, okay, I'm looking carefully and I see from the center, I go 1, 2, 3, 4. It's 4 units, right? So this is going along left and right, our x. So our x is going to be 4. We want it squared, so we're going to write 16. And up and down it goes. Is it lining up? Yeah. So we go 1, 2, 3. Up and down will be 3 units. 1, 2, 3. So we know the numbers underneath. So from your text, it reads, the distance from the center, negative 3 comma 1, to the vertices is 4 units left and right. So A is 4. That's how we got this number. Left and right, we went. 4 to the left and 4 to the right. So 4 squared is 16. That's where we get that 16 from. The length of 4, the minor axis, allows to determine the distance from the center to endpoint is 2. So B equals 2, and the final equation is as is. So we found this 4 by counting there was that didn't line up correctly. We said it was 3, but we're getting 2 because it says the whole thing is 4. The whole thing is 4, so half of it would be 2. So I'm moving 2 up and 2 down. So that's where we get that 4 from. And that's it for ellipses. To practice, let's do one of your homework problems. I know all this is so new, so let's take the time to practice it. So this is 5.2. Why don't we go ahead and do, let's do number 2. So it's number 2 from your homework. It's not one you have on the back of your book. Let's go ahead and graph 2. Our instructions read, graph each ellipse by finding the center, the vertices, and the co-vertices. Also state the location of the foci. So I'll give you 3 minutes, so until 5:50, and then I'll stop you, and we'll continue from where you left off. We'll do the whole problem together. This is from your homework, 5.2. Practice problems, we're doing number 2. Okay, let's go ahead and see where we're at. Now, the reason I like to give you a chance to do a problem is because sometimes when someone is walking you through something, you're like, yeah, I get it. And the moment you're by yourself, you're like, oh crap, what was happening again? So let's see where we're at. So we're being asked to graph this, and I'll try to color code. So let's go ahead by labeling our center. So if it doesn't tell us a number, we know it's a 0, right? If there's no plus or minus a number, so our H and our K. Our X, for H comma K, we're going to have a 0, and then we're going to have a -1. So I go to 0, down 1, I have this center right here. 0, comma, -1. Okay, moving forward. My X has a 12. So remember X, if you're ever unsure which one's which, look at your axis. Left and right, we have X, right? So X moves left and right. And for X, I have 12. I take the square root of that. Let's punch that into our calculator. So I have square root of 12. You get about 3.46. So let's round to 3.5. So I'm going to move to the right 3.5 units. So we have 1, 2, 3 and a half. We have this point right here. 1, 2, 3 and a half. This point right here. Let's label our points. So we have 1, 2, 3, 3.5, comma, -1. -3.5, comma, -1. All right. Up and down, I'll do in blue, but let me erase my little tick marks so you don't think I'm saying something that we're trying to say. All right, I'll do up and down in green. So underneath the Y, I have what's going to tell us to move up and down. Remember, your Y moves up and down. You can always take a look to your axis. Where is the Y? It moves up and down. So I have a 16. I take the square root of that. We get 4. I'm going to go up and down from the center 4. I have 1, 2, 3, 4. We're here. This gives us a point 1, 2, 3, 0, comma 3. 1, 2, 3, 4. We have this point here. This gives a point 1, 2, 3, 4, 5, 0, comma negative 5. So let's label our points as working through this. All right, let's go ahead and connect. So if I connect this, I get my image of my ellipse. So my ellipse looks like this. Try and make it as pretty as possible, but my ellipses always look not very nice. This is the hardest part for me. Ah, I failed. That's my horribly drawn ellipse. I'm glad it's muted because that way I can't hear your laughter. Okay, and we need to find our focus along our major axis. So you see how Y has a larger number? So let's just know that our major axis is the vertical one. It has the longer side, even though from my horrible image, you can't really tell which one is longer. All right, so let's use our C to find our focus. Our 2 focus points are foci. So I have C squared and then larger minus smaller. The reason why I don't write it using the formula is because it always varies. And sometimes when we memorize the formula, we can forget that it can vary. So that way, if you know larger minus smaller, it'll prevent a silly mistake. So I have 16 minus 12. That gives me C squared. 16 minus 12 is 4. C squared is 4. But I want C, not C squared. So I take the square root. That cancels square root. So we're left with C is equal to 2. So this means we're going to go up and down because our major axis is on the y-axis, up and down 2 from the center. So we go 1, 2. This is our focus point. That's the point 0, comma 1. We go from our center. We go 2 units, 1, 2. We have this other focus point at 0, comma negative 3. And we have drawn an ellipse. I hope your ellipse looks much nicer than my ellipse. Okay, so when we meet again on Wednesday, try your homework, come to me with your questions. I'll take questions from any homework assignment. Let's continue with hyperbolas. So hyperbolas. All right, I'll stop about the half hour mark. Let's see how far we get. 5.3 hyperbolas. Objectives. 1. The standard form of the equation of hyperbolas. 2. Graphing hyperbolas. And finding equations of hyperbolas. All right, so let me warn you. Hyperbolas will look a lot like ellipses. Hyperbolas have a minus, and that's what makes this equation totally different. Circles and ellipses have pluses. Circle and an ellipse have a plus. And that's a major thing that separates those two. A circle is never written as a fraction. An ellipse is a fraction, right? We have that denominator, but that plus is what makes an ellipse. Hyperbola and ellipse look very much the same, so be careful. Hyperbola equations. The equation of a hyperbola is a set of all points in the plane, the difference of which the distance from the two fixed points is called the foci, is constant. The only word in this definition that differs from the definition of the ellipse is the word difference. Difference meaning minus. In general, a hyperbola can be seen as an ellipse that is cut in half, vertically or horizontally, and turned inside out. As depicted in each of the following graphs, a hyperbola will either open up and down or left or right. So you see these horrible pictures? Everything that is dotted is just something that we keep track of. A hyperbola is what you see in red. That part you see in red, that's your hyperbola. Everything else is just helping us keep track of how to draw this. It has an ellipse in the center just so you can see what he means. So you cut an ellipse in half and you turn it inside out. And that gives us these ellipses. Now we can have an ellipse just like a circle opens, a circle can have a major axis up and down or left to right. So a hyperbola can open left or right or up and down, one of those two only. And we have these focus points, our foci, and they're in green. So let's go ahead and see these components written in words. The list of components involved with the hyperbola will include the following. 1, foci, 2 fixed points placed side by side or up and down from each other. Notice they're always inside within your hyperbola. So look at where your hyperbola opens. It opens left and right, and it's always inside, right? 2, center. The midpoint of the line connecting the two foci, also the midpoint of the vertices. So it's the center right here. The red dot, that isn't so noticeable, that's the center. 3, I'm sorry, the center is in purple. The center is in purple. And then vertices, the 2 points for the line through the two foci intersect the graph at the hyperbola. Constructing the text for the derivation of the standard equation of hyperbolas, have the standard equation of hyperbola with center HK and the foci side by side as x minus h squared over a squared minus y minus k squared over b squared equals 1. Similarly, for a hyperbola which opens up and down, because the foci are located one above one another, we obtain the second version of the equation of a hyperbola as y minus k squared over a squared minus x minus h squared over b squared. So notice they're very similar, but we always write the a first. And like always, the h and the k are attached to the x's and the y's, but you can switch up the order. And you might have to because the minus has an order. I need to write it in the order that's given, so I have the minus in between. All right, graphing hyperbolas. Consider the hyperbola x squared over 4 minus y squared over 9 equals 0. Since the equation can be viewed in standard form as x minus 0 squared over 4 minus 5 minus 0 squared over 9 equals 1, we can determine the center is 0, 0. Right, just like before, nothing really changed. For this hyperbola, which opens left and right, wait, how do we know it opens left and right? It matters which one it starts off with. So if it starts with an X, it opens left and right. If it starts with a Y, it opens up and down. That's what I meant by full size side by side. It means left and right. Okay. I think that's a major point of confusion there. Which one is it open? I mean, it has the same features as an ellipse, but we need to know how it opens. All right, so again, we start with the X, it opens left and right. So let's continue. For this hyperbola, which opens left and right, the two x-intercepts will be the vertices. Finding the x-intercepts we have, so we let y be 0, and if that's the case, if y is 0, that whole term is 0. So we're left with x squared is plus or minus 2. The same idea as taking your denominator and taking the square root of it. But I think the reason your text has to go this way is because I have a plus or minus. We have to do it both. We have to add it to the left and right. Okay. Now for your y, something funny will happen. Before we continue, let's consider what will happen if we try to find the y-intercepts for the hyperbola. If we try to find your y-intercepts, remember, y doesn't open up and down. So we try to find the y-intercepts, we let x be 0, so that's gone. And if we solve for it, we get y squared equals -9, which can't happen, right? You get an I. And there's no I in a coordinate plane. There's x's and y's, but no I. These complex solutions prove that hyperbola does not have any y-intercepts. Now for hyperbolas, b squared equals c squared minus a squared can be written as c squared equals a squared plus b squared. For our hyperbola, b squared over 4 minus y squared over 9 equals 1, we get c squared is equal to a squared plus b squared. So we add our denominators 4 plus 9, and we take the square root. We get 13, and square root of 13, we get 3.6. In case you want a calculator, 3.6, a number solution. The distance left and right from the center to the focus points, both sides. Since the vertices are also left and right of the center, we use our vertices at plus or minus 2 and our foci at plus or minus 13. You know, we have the graph depicted as below. All right, so you're like, what just happened? Let me write down your formula. So you have x squared over 4 and over 9. So we have x squared over 4 minus y squared over 9 equals, it always equals 1. Okay, we have a minus, so it's long ellipse. So it's getting these points. So we have to label our center. We find our center just before, which is 0, 0. We label it in purple. Okay, now I need to find these points of my hyperbola. So because your first number is a 4 and it's on the x, you're gonna go left and right 4. So I go, I'm sorry, left and right 2, just like before. So I go 1, 2, you have these points in red. Now we want to find the focus points. So from your center, you move that much more. So we have a 3.16. So from our center, we're going to go 1, 2, 3, and a bit more. So it gives us 3.6, 0, negative 3.6, 0, which is these points in green. How do we find that red image? We haven't really found that yet. It's just telling you what it's going to look like. Although this graph is fairly accurate depiction of the graph x squared over 4 minus y squared over 9 equals 1, we will finish our discussion of this hyperbola by determining the width of the two curves of the hyperbola by solving the equation for y. Starting with x squared over 4 minus y squared over 9 equals 1, we will move the expression x squared to the right side. So it has plus this number to both sides. And we multiply by 9, so we can get y by itself. So we multiply by -9 on both sides. So now we take the square root, we use the square root property. In order to determine the width of the hyperbola, we will consider the end behavior of the hyperbola with the equation written as y equals plus or minus the square root of 9x squared over 4 minus 9. As x is approaching plus or minus infinity on the shear side of the expression, 9x squared over 4 makes subtraction of 9 nearly irrelevant to the expression. So we have 9x squared over 4 minus 9 is approaching, so you disregard the constant, 9x squared over 4. Therefore, the hyperbola will approach the graph at y equals plus or minus the square root of 9x squared over 4, which can be simplified as y equals plus or minus 3 over 2x. The two lines with intercepts 0, 0, and slopes of 3 over 2. Now, along with our previous work, we found the vertices at plus or minus 2, so these points in red, and a foci at square root of 3, these points in green. I'm sorry, square root of 13, still those points in green. Our graph will open left and right with the line of y equals plus or minus square root of 3 over 2x. So it's this new line in blue. Before we move from this first example, we introduce a general process for graphing hyperbolas that will include a simpler way. I know what we did above was kind of different. I think it's just trying to explain more the calculus space as to how these numbers happen. But we can do this a bit simpler using techniques that we learned previously, like when we graphed an ellipse. So again, notice there's two different ones. So this one opens left and right, and this one opens up and down. How do we know this? Because it starts with x, and this is because it starts with y. That matters because that minus doesn't let you move things around. The minus is what makes an ellipse. 2, to determine the value of a, the distance from the center to the vertices, using this value to label the vertices. If a squared is under the expression involving the vertex will be left and right from the center, the same direction as the x-axis. If a squared is under the expression, you see how a is under y? If a squared is under the expression involving y, the vertices will open up and down from the center, the same direction as the y-axis. So whichever comes first lets you know which way our parabolas or our hyperbola are opening. They're like two parabolas put together. Determine the value of b. Use this value to mark 2 points of distance from b, the center of the opposite directions from the center of the vertices. Draw a dashed rectangle that passes through the 4 points found in step 2 and 3. So it's kind of like when you're graphing a ellipse. But instead of a circle, draw a box connecting these points of an ellipse. Draw a dashed rectangle that passes through the 4 points found in steps 2 and 3. Then draw 2 lines through the center of the hyperbola and outward through the corners of the rectangle. So it's saying from the rectangle you draw, use the corners to draw those slopes. 6, use c squared equals a squared plus b to determine the value of the c to label your foci. The 2 points, the distance from c from the center of the same direction as the vertices. Using the framework for example 1 a second time. So take 2. We're going to do the same thing, but a more easier process. Since the equation can be viewed as standard form as x minus 0 squared over 4 minus y minus 0 squared over 9 equals 1, we can determine the center is 0, 0. Cool. We have a center at 0, 0. A is squared is under the x, so a squared gives us 2. So we're going to add up and down 2 to get these vertices plus or minus 2 from the center. Same direction as our x. We have a b of 3 because b squared equals 9, and we have b equals 3. And we go up and down the units from the center. Okay, now we draw a box. So let me help you out here. We have our center. We're saying we're going to go up and down 2. I'm sorry, left and right 2. So I have 1, 2, 1, 2. And I'm going to go up and down 3 from our center. So I have 1, 2, 3, 1, 2, 3. And now here it's saying drawing a rectangular box through our 4 points. All right, so we're going to draw a box. We're going to draw a dotted box because this is not a graph. This is helping us determine an outline of our graph. And drawing 2 lines to the corners of the rectangle. So you see these corners? We're going to draw 2 more lines going through the corners. We have our outline for an ellipse. I'm sorry, for a hyperbola. Solving c squared equals a squared plus b squared gives us 13. So we have a foci of plus or minus square root of 13, and we said that was about 3.6. So we have plus or minus 3.6, comma 0. So we use that 3.6 units left and right from the center. So we have 1, 2, 3, and a bit more, something like that. And now we can draw an ellipse. So your ellipse is always along your major axis, which is always which one does it lead with. And it isn't always a larger one. So we know it opens left to right, so this is our hyperbola. You use these dotted lines as a guideline. They're kind of like asymptotes. We're never going to cross them. So from our vertex, we have our ellipse. We use that box to give us an outline of what we're going to draw. And here's a much prettier graph. Example 2. Graph y plus 2 squared over 25 minus x minus 1 squared over 16 equals 1. Okay, first thing you have to determine, which way does your hyperbola open? I'll wait for a response.
Up and down.
It opens up and down. Thank you. Opens up and down. And we know this because we start with a y, and y goes up and down. Now again, we have a hyperbola because we have a minus. Hyperbola. That lets us know we have a hyperbola. We can have the same thing with a plus, and we have an ellipse. But that minus gives us a different graph. And you have to make sure it's equal to 1. If not, we have to do more work. All right, so let's start off with some important pieces. So we have a center. And remember, it's always h comma k. The x is always with the h. So we have our h here. And the k is always with the y. So I have a center. Remember, I changed the signs. I have a -1 for the h, so I'm going to write +1. For the k next to y, I see a +2, so I know to write -2. Okay, I use these numbers in the bottom to draw a box. So I know from the center, I'm going to go up and down 5, and left to right, square root of 16, 4. It's always the square root of the bottom number. And that gives us an outline of the box. And from there, we're pretty much done. Okay, let's go over our outline. Since the equation is written in standard form, we can determine the following. The center is 1, -2. We have that. A squared is 25, giving A of 5. Take the square root. The distance up and down from the center of 1, -2 to the vertices is located at 1, 3, and 1, 7. So what this means is we're going to add and subtract a 5 from the 2. And sometimes when it's not drawn, it doesn't seem so obvious. B squared equals 16 and therefore B equals 4. The distance left to right from the center. So from the center, we're moving left or right, which is x. We're going to add and subtract a 4. So we get these new points, -3, 2, and positive 5, -2. Drawing a rectangular box with the 4 points, the 2 lines to the corners of the rectangle, we have the asymptotes. So let's try it just so we can put all this together. I think reading math is not the best thing to do. We kind of don't really see what we have. All right, so we know it's going to open up and down because it starts with a y. And we have a center at 1, -2. Let me draw it quick. 1, 2, 3, 4, 5. 1, 2, 3, 4. Have 1, -2, 1, down 2. That's our center. I know I will go up and down 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And I'll go left and right 4. From the center, 1, 2, 3, 4. One, 2, 3, 4. And with that, we draw a dotted box. And then from those boxes, we draw lines against the edges to draw our line y equals mx plus b with a slope. Okay, because we said it starts with a y and y goes up and down, we have a hyperbola going up and down from this point or vertex. And we're going to have a focus point. Right? We said our focus point is the sum of those two. So c squared equals 25 plus 16, which gives us 41. Take the square root. Square root of 41 is about 6.4. So from the center, you're going to go 6.4 along the parabola. So I have 1, 2, 3, 4, 5, 6, and a bit more. 1, 2, 3, 4, 5, 6, and a bit more. And those are our focus points. So we're here. We drew our dotted boxes using y minus y1 equals mx minus x1 with the slopes of the asymptotes at plus or minus 5 or 4, and each asymptote passes through the center. The equations of the asymptotes are y plus 2 equals plus or minus 5 or 4 times x minus 1. All right, so you're saying, where is this coming from? So you're essentially making a slope from those numbers 25 and 16, the square root of them. So it's the first one over the second. That's how they got this slope. And they're just picking a point from the center. So the center point, and they're using the formula, the point slope formula. I will not focus so much on the slopes of the line because you don't really need them if you have that dotted line. And for C, we just add our denominators, take the square root. Drawing the curves, we have the following graph that will have two curves through the vertices that open up and down, approaching the asymptotes of the curves, moving away from the vertices. So there we go. That's what we have. Now, it tells you how to find that formula for your lines. I don't really focus on that too much. As long as you can find your dotted box and go from there, I feel like you're in good shape and know which way it opens. Let's go ahead and do example 3 and then we'll call it a day. So let's go ahead and graph 2x squared minus y squared plus 4y minus 12 equals 0. All right, so again, we have a problem. It's not in standard form. We have two options. We can have x minus h squared over a squared minus y minus k squared over b squared is equal to 1. Or we can have y minus k squared over a squared minus x minus h squared over b squared equals 1. How do we know what order it comes in? That minus will guide you because that minus needs to be in between. Now you see how that y squared has a minus? That square that y has and that negative that y squared has lets us know that the y is going to come second. Meaning we're going to have this graph because the negative is attached to the y. Okay, now we just have to make it look like that. So we need to complete the square. As with circles and ellipses, the standard equation of a hyperbola contains only one copy of each variable, so we must complete the square with the y terms. Rewriting the equation above, we have x squared. We don't have an x, another x, right? So we have minus y squared minus 4, and we move the constant. So we add 12, we get equals 12. Okay, so I need to complete the square for the y's. So we have that b term, which is a negative 4. Negative 4 over 2, we get negative 2. Remember to square it, so we get 4. So we're going to add 4, but I need to ask permission and multiply it to the outside. So 4 times a negative, we do a minus 4 on the outside, which is what's highlighted here. We add 4 in the parentheses with the leading factor of negative 1. So we must also add the value of 4 times negative 1, right? To the right of each side to make sure we add the same amount to each side of the equation. Okay, we simplify, we do that work. So we have 12 plus negative 4 times negative 1, we got minus 4, we get 8. That's how this 8 happens. Okay. A big important point is we need to make this number a 1. Well, 8 divided by 8 is 1, so you always divide by the same number. Okay, so we're dividing each term by 8, which is here. Now we have to simplify. So 8 divided by 2, we get a 4 in the denominator. And in the bottom, for the y's, there isn't much to do, so it stays as an 8. Now we have it in standard form. Yay, that's so great. Now we can go ahead and find these pieces of information to graph our circle. I'm sorry, our hyperbola. So we have a center at h comma k, so 0 comma 2. We have an a squared of 4, which gives us 2. That's the distance from left to right. And we have a b squared of 8, giving us b is square root of 8, or 2 square root of 2. So you can always see the decimal form, and square root of 8 gives us 2.8. So square root of 8 is about 2.8. So that means we're going to add up and down from the center 2.8. All right, so let's draw what we have so far. So if I draw, okay, so let's draw some points. I might have to add more. All right, so I have a center at 0, 2. Zero, comma 2. Can I pass that? I went too far back. Here we go. At 0, 2. And then we're going to move. All right, X has that 4. So I know to move left and right. Square root of 4, 2 units. 1, 2. 1, 2. And then I have it square root of 8 for the y, so I go up and down square root of 8, which is 2.8. So I go 1, 2, and almost to the 5. 1, 2, and almost to the next number. So let's label our points. We have 2, 2, and we have 2, negative 2, 2. We have 0, 0.8, and we have 0, 4.8. And we draw that dotted box. Okay, now I have to connect the corners. Now you might be thinking, okay, which way does it open, up and down or left to right? Well, we start with an X. So I know we have a hyperbola left and right. So we go ahead and draw our hyperbola opening left and right. Last piece is our focus points. So we just use that c squared plus a squared plus b, a squared plus b squared equals c squared. To find our c. We can have our finished image right there. It's not so bad, right? It's just different. Okay, we'll go ahead and stop there. Let's do a homework problem. So let's do 5.3. Let's go ahead and do number 2. Let's do this together. Okay, so let's set up from the beginning which way it opens. Because it has a y, we know we're going to have a hyperbola with our 2 parabolas going up and down. Because our y-axis goes up and down, right? All right, that's settled. Let's label our center. Your center is h, k. Your h is always with the x, your k is always with the y. So we have it at 0 and -1. Okay, from here, just like an ellipse, I want to draw my endpoints. But instead of making an ellipse, these endpoints are going to make a box. All right. So I have my center at 0, -1. Let me draw my center. Let's go ahead and use these pieces. So I have a 12 for my y. Remember, your y goes up and down. So I'm going to take the square root of 12. Square root of 12 is 3.5. So we're going to go up and down 3.5 points. 1, 2, 3, and a bit more. So 0, 2.5. Go down 3.5 units. 1, 2, 3, and a bit more. We have 0, negative 4.5 units. All right, next piece, our x's. So x goes from left to right. Your x-axis goes from left to right. I have 16. I take the square root of 16. I get 4. So I go left to right 4. 1, 2, 3, 4. And this is 4 comma negative 1. 1, 2, 3, 4. And this is negative 4 comma negative 1. Okay, from here, we're going to draw our box. So I want to draw a box using my endpoints as a guide. And we connect our edges to draw another graph, another dotted line. Ooh, you did all this work and you haven't even drawn your hyperbola. Now we will. We said it's going to open up and down because we start with a y. Let's draw an up and down figure. So we have a y. Let's open up and down. Don't touch your dotted lines. Just get closer and closer and closer. And get closer and closer and closer. Good job. All right, last piece. We need to find our focus points. Or plural or foci. This formula is the same but different. So instead of minus, it's plus. B squared plus B squared. So we're going to add our denominators. So we have 12 plus 16 gives us C squared. 12 plus 16, yeah. 12 plus 16 gives us 28. All right, we take the square root. So C equals the square root of 28. Let's punch that into our calculator. You get 5.29, so 5.3. About 5.3. All right, so from the center, we're going to count 5.3 units going along our hyperbolas, our graphs in red. So I have 1, 2, 3, 4, 5, and a bit more. That's a focus point. So that's at 0, comma, 1, 2, 3, 4, 4.3. All right, from the center, we're going to go 5.3 down. So I have 1, 2, 3, 4, 5, and a 0.3. And that's a 0, comma, 4, 5, 6, 7, 7.3. That's 6. 6.3. Yeah, 6.3. Okay, we have drawn a hyperbola, labeled the center, drew our hyperbola in red, and labeled our foci. Now, just like an ellipse, we use those same points to draw an ellipse, but instead of drawing a circle-like figure, we're drawing a square box to help us guide us through drawing an ellipse. All right, let me take a look at your homework. I think you can do all of these. Yeah, it looks good. Let me go back to our Zoom conference. So who's still there?
I am.
Yes. Thank you so much for sticking around. I'm always so happy for this class and the good turnout I get. I'm so happy to see that you're still here and you're still continuing your studies and trying to make the best out of this such a different and weird situation. But as always, in case you're going through your homework and something seems weird, I'll post a recorded lecture of this. So I'll give you a link, and then soon I'll post it onto YouTube. So if ever that link doesn't work, just go onto YouTube and you'll find this recorded lecture there. You can find it by the date. All right. So are there any questions before we log off?
No, thank you.
No? Oh, when is the next homework due? Okay, so your homework is due on a, so you know how before we would have that week and it will be due on the Monday? Well, same thing, but instead of a Monday, I'll give you till the Tuesday, just in case you have some questions for that Monday lecture. That we can go back and do your homework and give that a try. So your homework is due the following week on a Tuesday. Did I say Friday at some point? On a Tuesday. So it's always due on a Tuesday. If for some reason you fall behind, that's okay. It'll be late. You lose half a point for that section, but you can still turn it in. Just go ahead and turn it in. It'll just be marked late and you'll get a slight point deduction. But not enough to where it's not worth doing. It's always worth doing, at least for the practice. And those homeworks are open until our last day of class, which is May 18th, Monday, May 18th. All right, so get that homework done. I'll be happy to answer any questions either at the beginning or in class. Does your SI have an announcement? Andrew, would you like to say anything?
No, nothing from me. Just have a good weekend, everyone.
All right, well, have a nice weekend then.
Ms. Bakari.
Yeah.
There was 12 pages to the 5.3. The last 4 we didn't get to. That's fine. We didn't need to.
I'll continue from there. I just don't want to make these Zoom lectures too long because I before in class I'll give you guys a 10-minute break in between, and now I don't want to kind of just have you linger around for 10 minutes for a break. So I think stopping at 1 hour and 30 minutes is good. We'll just continue from there on Monday.
Okay.
So we'll finish 5.3 hyperbolas on Monday. All right, thank you for asking. I'll go ahead and log off now. Have a nice weekend.
Thank you. Bye.
Bye-bye. Thank you, bye. Thank you, have a good one.